Hello, this is Sang again. Okay, so last time we were working on, uh, you know, uh, why do we want to work with vectors? And we saw that in physics, you know, uh, there was a reason to add and subtract these arrows, right? To find some to find forces, right? Summation of forces. Well, let's continue and take a good look at how we do these adding and subtracting of vectors. Here we have two vectors, A, right, vector A is at 3 and 4, and vector B is at 7 and 4, x and y axis, right? So to add vectors, two vectors, we all we do is we take this second vector and we're going to put it on top of the first vector, right? Without rotating it or shortening it or anything, just take it and plop it right on top like that, right? So A, B, and the resulting vector we call C, right? And it goes from the origin, or not necessarily the origin, but just the beginning of the first one to the end of the last one. So, and that's going to be at components 8 and 10, right? So this is called the tail to head method, and that's done graphically, right? Now we want to see, well, would this be the same if we? How would we do this, and would it be the same if we did with components, right? So let's go ahead and take a look at the component form. Okay, here we are. So A, like we said, right? This A vector equals so it was 3x hat plus 4y hat, right? So in B vector we still have this was at let's see, where was B at? 7, right? 7x hat, and it was also at 4y hat. Now to add, it's simple, right? To add in component forms, all we do is we add the components. And this is 10x hat plus 8y hat, right? And we just pick them out, right? We can see that it is at vector C, right? A plus B equals C hat equals component form. That's the component form. And let's take a look here. Is this correct? No, that's wrong, right? Because we count this up. X is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is wrong. So this is actually supposed to be just at 10 and 8, right? Because x is at 10, y is at 8. And we can just see that clearly from the component form here, right? Now, we want to say, like, use, like in numbers, we say something like 1 plus 3 equals 4, right? But we can also reverse that and say 3 plus 1 equals 4. Now, is that the same with vectors? Can we do these things? Can we switch it around and see if it's the same? Is A plus B equals B plus A? So that's the question we want to see. And that will have to do with what is called, we can show it graphically by the parallelogram description that would indeed show that A plus B does equals B plus A, just like in the number system, right? So let's go on. So that was adding vectors, right? And finally, let's see what some examples of a vector is. So for examples, so like we said, forces were vectors, right? But well, what is not a vector, right? For example, is speed? Is that a vector? Or is temperature? Is temperature a vector? Are these vectors? Now, remember, vectors have to have a magnitude and a direction, right? So clearly, speed, you can say it's like 45 miles per hour, right? And that only has a magnitude. Remember, we said magnitude was length, right? And here we can represent the magnitude the length of the arrow with a 45, but it doesn't have a direction, right? What about the temperature, right? We can say it's 100 degrees in LA, downtown LA, and that's just one number, and it doesn't have a direction. So those two things are not, but you know what is a velocity, right? So what velocity is, it's a technical term that says speed plus direction, right? And that indeed is a vector, right? And like we've seen before, right? The force diagram of a mass. Let's say a mass is falling under the force of gravity, right? So force equals mass times acceleration, right? Now is this a vector? This is also an example of a vector, right? Because here we can see the force is pointing down. Down is the direction, right? Because it's falling. And what is the acceleration or the force? Acceleration is 9.8 meters per second square. Now that's gravity, the acceleration of gravity. So we can see that it has a magnitude and it has a direction, and so force because of acceleration is also a vector. And so that's some examples of vectors, and we will see in the next series we're going to expand on more of what a vector is and how is it used, for example, in matrices. Okay.